After downloading the repository from my GitHub, you can go into the bin directory to find the executable files. You can run the converter with infix to postfix expression by running the executable as follows, and you can put the infix expression with the space in between the operator and numbers and press enter, and you can press either next to go to the next step, or you can go back a step. Now once every steps have been finished, it prints out the result. So the result will be the postfix expression for the inputted infix expression. Now I can continue to enter new expression, or you can press Q to quit. And let's see the calculator also. So in this one, you have to input the postfix expression. Now it does the same. It goes to the next step by pressing next. I can go back a step by pressing back as well. Once everything is finished, it prints out the result of the expression. So this is the answer for this postfix expression. Now to explain the organization of the code of this project, we can go to the lib folder inside the repo, and you can open up the main file, which is RPN UIA. The RPN stands for reverse Polish notation, which is synonym for postfix expression, I guess. So this has all of the classes that are required or included in this project, and the important ones are the CLI, which is the driver code for the executable. So this one actually runs the executable. So you can see that please input the expression, press Q to quit. So this is driver, main driver code. Another one is the table, which is responsible for rendering the table. So it has headers and columns and other settings that you can set inside the table class. And the valid operators are defined inside operator class. So here you can see that the bracket is not here, and the number represents the strength for each of the operator. So now you can see that the exponential has the highest power among the operator, and plus and minus has the weakest. And this one is also responsible for comparing which one is the stronger of the two operator when you're converting or calculating between infix to postfix expression. And iterator is defined in converter and calculator class. So either of it is injected into the CLI run method to run the executable. And the CLI class calls the next method of the converter or next method of the calculator, depending on whether user pressed the next or the back option. Now to see the example, converter class has a next method that goes to the next step and back method to go back to the previous step. Similar methods are defined in the calculator class as well. It has a next method which calculates what should be done to proceed to the next step, and also a back method to go back to the previous state. So when we look at inside the executable file, we just inject converter class into the CLI run method with the corresponding title, and it does the same for the calculator as well. So it has a title, and you just inject the iterator, calculator in this case, to the run method. So when you want to add another similar iterator, you just need to define the next method and back method and inject it in here to run the driver, CLI driver code with the table and the next and back button and also the quit. And when everything is finished, it prints out the result. I have also included the spec file that actually tests your code to make sure that everything is intact and not breaking. So let me just so let's see a calculator class and the corresponding spec file. So in the spec file, the behavior of the next method of the calculator class is defined in details depending on what are the inputs and what are depending on different context in which next method is called. So when the input stack becomes empty, it has to return false. And when I change the piece of code, let's just say this one here, let me just change to false. Then the spec file should alert me that something went wrong, as you can see here, and you can inspect the result, expected result, and what actually got produced with my actual code. So it shows you exactly how it went wrong and what should have been the correct result. We can easily fix this with changing back to true. It runs the spec file and you can see that there's no errors. So these are all of the behaviors for each classes and each methods defined inside the class. So whenever you add new functionality or whenever you refactor some of the code base, when any of the existing code actually breaks some of the code elsewhere, this spec file is there to alert you that what you actually did just now actually broke some of the existing functionality somewhere else in the code base. Alright, so I think this is it for this project. Thank you for watching, and I hope you enjoyed the video. Thank you.